Here's our last chance to show that we know the difference between a population distribution and a sampling distribution. So our population is all the rock and roll songs, and our sample is 40 that we're going to choose for programming. Okay, and so we are supposed to, well, first of all, here's our population statistics and population parameters, excuse me. That's our mean and that's our standard deviation of our population. How would you describe the sampling distribution? Well, this is a Unit 1 topic. How would you describe any data display? Shape, center, spread, and outliers. In this case, we really don't need to think about outliers. We haven't been told about any. But the shape, well, the central limit theorem tells us with a sample of greater than 40 that this will be approximately. And this word was key in the grading guide. They said to mark it wrong if you didn't have roughly or about or approximately normal. And then the center and the spread are, in fact, the mean and the standard deviation. But what do we know about sampling distributions? The mean of this sampling mean is going to be exactly the population mean. That's one of the amazing facts that comes out of the central limit theorem. And that was indeed 3.9 minutes long. What about standard deviation? Well, this is the standard deviation of the sampling mean, and that is actually much smaller. That's going to be sigma divided by square root of n. So we take our 1.1, divide it by square root of 40, and get something like 174, I think. With part B, we're given a probability problem, and that is, what's the probability of going over? Going over. We have 160 minutes to work with, and we've got this expectation that a song is going to be 3.9 minutes long. But what is 160 minutes to us? Well, 160 minutes divided by these 40 songs on our playlist means that we can have up to an average of 4.0. So that's really what we're testing here. If we look at the distribution here, we are sampling 40 songs out of this population, we still expect that sample of 40 to have a mean of 3.9. And now we're asking ourselves, what's the probability we get in trouble with the boss here? The radio station manager knows that we can only go 160 minutes, so our average needs to be 4.0. And it looks like there's a good chance, the white portion here is the good chance of us meeting that expectation. But this red area is what we're being asked about. What's the probability that we go over, that we exceed? Okay, so we would, if you're doing this by hand, you would calculate a z-score, and 1 divided by our sampling distribution, standard deviation, is what, exactly 0.1 divided by 0.174, and you get a z-score of 0.57. You look that up on the table. Now, if you look up negative 0.57, that will tell you the area of this tail. If you look up the positive value, you'll need to subtract 100% minus the white area. And so, you know, if you did look that up, that would be 7157. But the area that we're actually interested in is the complement, which is 2843. And we are done.